This section we are going to talk about L'Hopital's rule. So first thing first, we have to talk about 7 indeterminate forms. So look at the picture. There are 7 indeterminate forms: 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, 0 raised to 0, 1 raised to infinity, and infinity raised to 0. What is indeterminate form? Indeterminate form is when we have encounter any one of this. So let's say 0 divided by 0. We don't know what that equals to. That cannot be determined. So that's why I say that these are indeterminate form. And then L'Hopital's rule applies to 2 circumstances only: 0 over 0 and infinity over infinity. Okay, no other exception. Only applies to 0 over 0 and infinity over infinity. How do we do L'Hopital's rule? So first, let's say we have a limit as x approaches to a. We have a rational function, a function divided by another function. How do we know that L'Hopital's rule is applied? So first, you have to plug in the x into the function to see if you have a 0 over 0 or infinity over infinity. If you do have either one of this, 0 or infinity, then L'Hopital's rule applies. How do we do L'Hopital's rule? So here is how. So you are going to write h and then equal. So what does that mean? What is h mean? H means h means we are going to apply L'Hopital's rule. So we have limit as x approaches to a. How do we do it? L'Hopital's rule. Listen carefully. You take the derivative of the top divided by derivative of the bottom, g prime of x. Again, L'Hopital's rule apply, and then you say equal. You always start with an equal, and then you write an h. H, you are telling your grader, I am going to apply L'Hopital's rule right now. And then you have f prime of x divided by g prime of x, means you take the derivative of the top, and then you take the derivative of the bottom. Again, you take the derivative of the top, draw a fraction bar, and then you take the derivative of the bottom. This is not quotient rule. So what I just wrote on my notes, this is not quotient rule, all right? Not quotient rule. And then what's next? After the derivative is done, you plug in a to see if you still have infinity over infinity or 0 over 0. If you do, you do L'Hopital's rule again. You keep doing this until you get out of 0 over 0 or infinity over infinity. That is L'Hopital's rule. All right. So on the next page, we have 6 functions right there. We are going to apply L'Hopital's rule, but before we start, I have a list of differentiation formulas. L'Hopital's rule is about application of derivatives, so we are not going to discuss the differentiation formula in detail. So if you never have that, take a screenshot of that. All right. And then I am going to solve the first problem. So let me move on to the first problem. So number 1, we have limit as x approaches to 1, and then we have x to the third minus 2x squared plus 1 divided by x to the third minus 1. And then how do I know L'Hopital's rule is applied? The answer is you have to plug in x equals to 1. So you plug in x equals to 1. So you have 1 to the third minus 2 times 1 squared plus 1 divided by 1 squared minus 1. So that is equals to 0 over 0. So that means L'Hopital's rule is applied. And then you draw an h equals to, and then limit as x approaches to 1. You take the derivative of the top, so which is 3x squared minus 4x. The derivative of 1 is equals to 0. Again, I am not doing quotient rule right now. This is only a simple power rule on top, and then the bottom, the derivative of 3x to the third is 3x squared. Now, don't rush to another derivative. Plug in 1 to see if that works. If you can plug in 1, evaluate the function right, evaluate the limit right now, then you don't need to do any other L'Hopital's rule. So you plug in a 1, you have a 3 minus 4 divided by 3, that is equals to negative 1/3. Then this is our answer. All right, so that is number 1. Number 2, I don't want to keep going back to the top. So if you want all 6 problems, you can take a screenshot right now to get all the 6 problems down, and then you can work on it. right? So let's do number 2. So number 2, let's change color for each problem. So number 2, we have a limit as x approaches to pi over 2 from the right. We have cosine x divided by 1 minus sine of x. Okay, let's plug in pi over 2. So we have cosine pi over 2 divided by 1 minus sine pi over 2. Look at your unit circle. What is the coordinate of pi over 2? That is x equals to 0, y equals to 1, right? So this is 0 divided by 1 minus 1. So that is 0 over 0. So that means L'Hopital's rule is applied. All right? And then you have to draw an H. You must draw an H. This is very important. Otherwise, no one knows what you did. And then you have limit as x approaches to pi over 2 from the right. The derivative of cosine is negative sine. And then the derivative of 1 is 0. The derivative of sine is cosine. Again, I did not do quotient rule. Okay, I take the derivative of the top and then derivative of the bottom. This is not quotient rule. This is L'Hopital's rule. And then you have limit as x approaches to pi over 2 plus, and then you have a tangent x. So tangent is the y coordinate divided by the x coordinate. So y coordinate is 1, x coordinate is 0. So we have 1 divided by 0. And what should I do? Then you have to take a look at the graph of tangent because we have x approaches to 2 from the right. So if you look up the graph of tangent, you have this, right? So this is the x-axis and the y-axis. And then let's sketch one curve. So we have something looks like that. And then what is the vertical asymptote? Here is the vertical asymptote, right? So the vertical asymptote, this is at pi over 2. This is negative pi over 2. And then let's do one more. So we have one more piece. And then this is a 3 pi over 2. So what is the function equals to as x approaches to pi over 2 from the right? Take a look. As x approaches to pi over 2 from the right, we are talking about this piece right there. Y approaches to negative infinity. So that is your answer. All right. So moving on to number 3. Switch color again. Number 3. So we have limit as theta approaches to pi over 2. We have 1 minus theta, sine theta, divided by 1 plus 2 cosine, oh, it's not 2, 1 plus cosine 2 theta. Cosine 2 theta, first we plug in a pi over 2, 1 minus sine of pi over 2 divided by 1 plus cosine, 2 times pi over 2 is pi. So pi over 2, the y coordinate is 1, and then cosine pi, the coordinate of pi is here. The coordinate of pi is x equals to negative 1, y equals to 0. So that will be 1 plus negative 1. Then this will be 0 divided by 0. Then L'Hopital's rule is applied. And then you apply the rule. Limit theta approaches to pi over 2. The derivative of 1 is 0. The derivative of sine is cosine. Derivative of 1 is 0. And then derivative of cosine 2 theta is, you have negative sine of 2 theta, right? And then the derivative of 2 theta is equals to 2. Then you multiply by 2. So this one we have limit as theta approaches to pi over 2. Let's get rid of all the minuses. So we have a negative on top, negative on the bottom, right? So that means we end up with cosine theta divided by 2 times sine of 2 theta. Are we safe to plug in? Let's try. So we have cosine pi over 2. Cosine pi over 2 is 0. And then 2 times pi over 2 is pi. Sine of pi is also equals to 0. So we still have a 0 over 0 after we apply L'Hopital's rule one time. So that means we need another L'Hopital's rule. And then we just do the L'Hopital's rule since we need it. So that is limit as theta approaches to pi over 2. We take derivative again. So as you can see, the function is getting simpler and simpler after we take derivative again, and again, right? So the derivative of cosine is negative sine. And then the derivative of sine is cosine 2 theta, right? And then times 2. So since we have another 2, that is equals to 4. Are we safe to plug in? So if you plug in pi over 2, the top, you have a 1. And then the bottom, cosine of pi is equals to negative 1, right? So this one we can just plug in negative sine of pi over 2 divided by 4 times cosine of pi. So this is negative 1, right? And then 4 times pi is 4 times negative 1. So that is just equals to 1/4. So that is the answer of number 3. And then moving on to number 4. So number 4, switch color for every single problem. So number 4, we have a limit as x approaches to infinity. We have ln x divided by the square root of x. So ln x, the graph is this. As x goes to infinity, y goes to infinity. And the square root function, this is the graph as x goes to infinity, y goes to infinity. So therefore, we have infinity divided by infinity. So that is a L'Hopital's rule. So we have L'Hopital's rule. X approaches to infinity, the derivative of ln is 1 over x. The derivative of the square root function, you bring the square root down, and then 1/2 minus 1 is negative 1/2. You have to reposition all the x. I cannot work with complex fractions like that. So that is limit x is approaches to infinity. We have, okay, this one I don't want to skip any step. This, we have 1 divided by x times 1 divided by 1 over 2 root of x. So this thing will just flip back to the top, right? And then you have a limit as x approaches to infinity. You have 2 root x on top, and then you have a square root of x in the denominator. And then the top is 1. The top is 1/2, right? The top is 1/2, the bottom is 1. So we take 1/2 minus 1. 1/2 minus 1. So we have x to the negative 1/2. So this function is limit as x approaches to infinity, 2 divided by the square root of x. Take a look at what I just did. I only apply L'Hopital's rule 1 time so far. So after you apply L'Hopital's rule, the x will be just all over the place, right? And then you want to reposition the x, simplify as much as you can, and then you plug in x to see if you need to apply L'Hopital's rule. Don't just keep applying L'Hopital's rule. You will get the answer wrong. Okay, apply the L'Hopital's rule 1 time, simplify as much as you can to see if second L'Hopital is necessary. So in this one, it is not necessary because once we plug in, we have 2 divided by the square root of infinity. That is 2 divided by a huge number. We talk about this back to limit. When you take 2 divided by a very large value, the result is just equals to 0. All right, so moving on to the next one. The next one is pretty long. Number 5, we have limit as x goes to 0. We have x minus sine of x divided by x minus tangent of x. Okay, do we have 0 or infinity? So we have 0 minus sine of 0, which is 0, and then tangent of 0, that is also equal to 0. Then we have 0 divided by 0, so that is a L'Hopital's rule. And then we go ahead and do L'Hopital's rule. So we have limit as x approaches to 0. 1, the derivative of sine is cosine, derivative of x is 1, derivative of tangent is secant square. And then we plug in a 0, right? So we have 1 minus cosine 0 is 1, and then secant square 0, that is the square of 1. So we have 0 divided by 0, so that is another L'Hopital. Then we do another L'Hopital. So we have limit x approaches to 0 again. I have mentioned this like 18 times. I am not doing quotient rule. This is L'Hopital's rule. The derivative of the top and then the derivative of the bottom. Derivative of 1, derivative of cosine is negative sign, right? So you have minus a negative sign. And then derivative of 1 is 0. The derivative of secant square, what do? You bring the square down, so 2 secant x. And then using chain rule, the derivative of secant is secant x tangent x. I know if you don't catch that, this is a chain rule. And then we try to simplify as much as we can. At least I can see that there is a negative 1/2 to pull out. X goes to 0. There is a negative 1/2. And then I see a sine divided by a secant tangent, right? So we have a sine of x divided by a secant square x times tangent x. And then here is something that you have to practice and you have to get experience. I am trying to simplify this, right? If you don't just plug in a 0, I need to simplify this. How to simplify this? I am going to put the tangent back to the top. All right. So this is a limit as x approaches to 0. We have negative 1/2. And then we have sine of x, and then 1 divided by tangent. That is the only way to put the tangent on top. Divided by secant square x. And then other than that, I am going to change the secant square to 1 divided by cosine. We have negative 1/2. So the top, I have sine of x times sine x cosine x, and then divided by 1 over cosine square x, and then I can bring the cosine square to the top, right? Oh, by the way, just make a mistake. This is 1 over tangent, right? 1 over tangent is the same thing as cotangent. So this is a mistake. I will just like cross this out. So 1 over tangent is cotangent. So that will be cosine x divided by sine x. So the sine x can be cancelled. And then you have limit as x approaches to 0, negative 1/2. So the sine is cancelled. And then we have a cosine x. And then flip the cosine square x to the top, then cosine square x, we have a 1 right there. Then this is a cosine to the 3rd power. So limit as x approaches to 0, we have negative 1/2 cosine to the 3rd power x. So now it is safe to plug in 0 because cosine of 0 is just equals to 1. Then you have negative 1/2 times 1, that is equals to negative 1/2. So that is the answer of problem 5. Okay, so let's do the last one, and then I can do a few more in the next video. Number 6. Number 6, we have limit as x approaches to 0. We have x times 3 raised to the x power, 3 raised to the x power minus 1. So we plug in a 0. We have 3 to the 0, and then 3 to the 0 minus 1. What is 3 to the 0 power? That is 1, right? Not 0, right? Minus 1, and then the top is 0. So that is 0 divided by 0. That is a L'Hopital. And then you go ahead, apply the L'Hopital. What is the derivative of 3 to the x? So that is 3 to the x. And then ln 3, right? Derivative of 1 is equals to 0. So now the top is a product rule. What's the product rule? The product rule is fg prime plus gf prime. So fg prime, you copy f, and then the derivative of 3 to the x is 3x ln 3, and then plus g. The derivative of x is just equals to 1. And then what we can do is, I am going to factor out the 3 to the x. So we have x times ln 3 plus 1 divided by 3 to the x times ln 3, right? So the 3 to the x got cancelled. And then, can we plug in? I think the answer is yes. 0 times ln 3 plus 1 divided by ln 3. So that is 1 divided by ln 3. You don't have to approximate that. So this is our final answer. So that will be all in this video. In the next video, I will introduce a couple more examples using L'Hopital's rule. If you think the video is helpful to your study, please subscribe, give me a like, share this video all out for me. I appreciate your help really much. I see you in the next part.